All right, thank you very much. And thank you for the time, lecture. And compared with all the talks you have heard before, this will be a walk in the park. In the sense, the term network efficiency is what actually everybody here lives and breathes every day, even consciously, unconsciously, right? So what we are trying to do is say, you heard this term many, many times, and people talking about this, company executive talking about this, but what actually they did to improve or even measure this important quantity. What I'm trying to do here, I think you are going to do with me together, put your architecture hats on, put your mathematician hats on, put your management hats on, you think about how actually we can or we should do to our company or to your network in this important quantity, right? So he thinks we need to define anything we want to talk about clearly. Number two, we need to quantify. Without these two things, we're just talking smoke. So that's what's very important is to say we need to be numerical. So network efficiency. So what is a network? Network is a bunch of equipment and put in geographically different locations by a bunch of people and hook it up and run by another bunch of people and based on the rules set up by another bunch of people. And for the purpose of moving digital information around, and then to do what? To fill some company's business goals. Like for a service provider, we want to sell this transmission and make money. That's the whole thing, right? So when we talk about network efficiency, we need to keep all these different components in mind and see what they have. So if we were moving bits around, we need thinking about capacity and how efficiently you can use that hardware and software to do this job. And we need to know how people manage this thing and how the network actually performs. And also what exactly this network is doing to fulfill your business goal as what you intended originally to do. So all these things need to work together in one way or the other actually to make sense. And you can think from your own company. Sometimes they express one thing and but omit the other thing. Sometimes we do all kind of jumping around and trying to figure out what exactly is going on with our network. So if you think about efficiency and with all these three different components, and maybe one of the simplest way you can define that would be this simple formula. Basically, you have two terms, which is the capacity and the operations. They are affecting your bottom line. And also you have a service efficiency, which affects your top line. And the very important we have to think about is say, if these things could be in conflict with each other, and if you don't do it correctly, and then you are not going to make a good business decisions. One very important thing is about the service efficiency, right? So a lot of things, as we are as engineers, we're geeks to do all things technically advanced or fancier and all that stuff. However, we cannot use that to impede your business goals. And the management make decisions based on all kinds of decisions, but are these decisions actually going to advance your business or the other way around? So it's very important. This is not just engineering criteria, also is the business criteria, standards. So let's go back and talk about service, right? This is a very important thing. This is how the purpose of the company exists to do this thing. So what is the service efficiency in this particular case? So you see the first component, which is how do you bring a service or product to the market or to your network. And the second term would be how do you actually procure customer onto this network. And the third term would be how you are spending money to make this thing happen, right? So you see that we use a timeline there to define these efficiencies. The last one is you see using a capital S to represent dollars, right? I don't want to put a dollar sign in there, look too greedy. And so you see anywhere you see a large S, you represent a dollar sign, right? So it's a number. So very important thing is here you see any decisions, especially we see in my company, in many other companies, And when you do not, when the management cannot identify what is coming, what is the most important business currently in the market, how do you make money out of it? And if you spend years' time to develop and going back and forth, you're losing what? You're costing you a huge amount of opportunity cost. This is one term that in many places is completely ignored. People don't understand it, and people don't think about it. Opportunity cost actually, from what I stand in my company, is that I think that's a major problem, that people not making decisions based on the actual the business goals, but using some other process and procedures. You see that indecision, lack of a vision, and very slow to reaction, right? So here, in this day and age, I think all the SDNs, NFVs, and all these new trends is trying to make sure this service part is meeting the market demand. From operation perspective, that is very simple defined here, is basically how much the cost and to operate your network compared with your total capacity, and also do you actually has any operational involved errors which are causing you problems. So operational cost defined above is actually involves both people and tools, right? And many places now we want to automate, we want to bring tools into the network. And on the other hand, we want to reduce staff. And so you trust algorithms or you trust humans. And many companies, executives say, okay, I want to save money, I want to trust algorithms. But still, humans are your most important, precious assets. So you have to treat that carefully, especially the experienced staff here. And then we talk about capacity. Capacity is what we do here, right? Can be defined in many other ways. Either it can be measured as your, in the normal time, what's the peak network utilization, or during failure, what's the peak utilization, or how much money you spend on the edge versus on the core, because the core is a cost. Edge is where you're generating your revenue. So how you do that part defines how you run your capacity effectively. Or you can say, okay, what is my working capacity, meaning what's the minimum capacity to run the traffic with no failure, plus how much additional capacity you need to add to the network and to fulfill your failure protection requirements. Of course, if you have a network triggered network events, if it becomes capacity, then it also degrades your capacity. So this is like multiple angles to evaluate the same thing, and all different layers of the network will affect this particular number. So in some general rules, you say you have to deal about business goals and RSAs, which are basically defines the traffic behavior during failure. In normal cases, we always carry the traffic through, but during failure, you need to know how should we run, design the build network dealing with failures. And so you have different classes of traffic, and you can have a maximum failure time scale. You do not want the packet loss to last too long. And you have your QoS policy, you have a latency constraint. Also, you have to do either you protect single failures, and sometimes you also need to protect your multiple failures. But protecting multiple failures is exceedingly expensive, so you have to be very careful picking where and when you do that. And for network topology in your design, how do you optimize? We have to remember the traffic patterns. Usually it's a function of time. And people from different layers looking at things differently, especially in the transport folks that give you a single track pattern and say, okay, if you do this, I can save you 30% of your capacity. You can tell them, no. If I change the traffic patterns in the next 5 minutes or 2 hours, and your entire model breaks down. That 30% becomes 5%. So we have to think about that part. IP traffic is highly bursty, and also your fiber plant and the diversity requirements. So from a traffic capacity efficiency perspective, right? So what's affected by the different layers of the network? Optical layer, and it's wavelength based, and it used to be the lowest cost. Very important thing when the coherent technology come along, we go into 40 gig and 100 gig, and now you eventually go into 400 gig and terabits in the future. Optical wavelengths becomes a lot more expensive and becomes larger portion of your network cost because the optical becomes highly expensive. The router ports before, when you go to OC192 years ago, that was very expensive. You do a lot of gray optics connections between the router ports and the transmission lines, and it's very expensive. That's why at the time people were talking about integrated router and DWDM, meaning you can put the DWDM port directly on the router to save that gray optics. But now things change, folks. That colored optics becomes a lot more expensive than the gray. So how do you do your integration becomes a very important piece. Also, in the optical layer, you have no statistical maximum. So the next one up is OTN. The OTN layer is very similar to the optical. It's just like the SONET before, right? In that layer, and you have, because it's already doing OEO, it's already doing OEO transition, you can do a very fast protection scheme. However, no statistical maximum, and you need idle capacity to protect. And next is our layer, Ethernet, the IP, and MPLS. That one, even though it requires OEO, so however, because the statistical maxing and we have all the traffic engineering tools there is, and that's probably where the most versatile and reliable protection there could be. On the other hand, there is a question. Why all these layers at this point of time are still separate? When we do all these things, we talk about, say, we need to avoid the race condition, right? Optical people want to do the protection themselves. IP people say, I want additional capacity on the top. So during a failure, that could be a race condition between different organizations in your network and trying to do different things. You definitely want to avoid that. So this one particular slide is the whole purpose I come over here to talk to you guys. So that could be a reason. That could be a driver, and could be a new technology. Optical and IP can be combined. I mean, I cannot say too much about this because it takes a lot of time where I talk about it somewhere else. But here, let me give you this thing. And if you don't know about OTN by any detail, let me give you one example. A decade ago, OTN coming to line compared with SONET. SONET, what is SONET? SONET is a fixed frame rate of 8,000 frames per second, no matter what speed it is. So when the speed gets higher, the frame size gets higher. It becomes unmanageable. ITU come up with this new thing, which is great, which is revolutionary. They choose a fixed frame size, then changing the frame rate when you go to higher speed, 16 kilobytes per frame. Think about this. Compare with our normal transportation in the natural world. The container ship come into business 30 years ago. That completely turned the transportation business around because you have a fixed size. You can do whatever you want with it. OTN is the same thing. The only problem is a big problem. Is when they invented OTN, it's a bunch of people who are working on SONET. They have no clue, have no desire, they don't care IP. What do I mean? They don't care what is inside that frame. If it's completely empty because there's nothing there in transmission, they send it out. It's every single bit in, every stuff bit in going in, every stuff bit goes out. So you can imagine in the ocean, we have a bunch of container ships rolling around. 50% of them are totally empty. Some of them are 25% filled. If all these harbors in everywhere, the loading of containers is using a fixed rate, you see here, SONET is a fixed rate. Using a fixed rate, no matter you have stuff in it or not, they just send a container on the ship. Our transportation business were bankrupt by long ago, right? It's going to be crazy. So how come we as a customer using this network, and they are putting in the container ships all over the place, and 50% of them or more are empty, and we don't do anything? Why they don't care? That's the problem. Can we fix it? That's what I said there. There's think about this, right? Here is synchronized network. Every single frame is going out on a line every single second. It's not like IP. Sometimes you have packets, sometimes you don't. Do you think we can find a way to actually make that container IP aware? Fill it up. Fill it up, easy. Put buffer there, fill it up. At 100 gig, it's 3 microseconds per frame. Then you send it out. You put some bits there, say, okay, this guy has something in it. This guy does not. Anywhere you need capacity, drop that damn empty frame and only send one with stuff in it. So how the whole transportation network should work. You route these things basically just like IP. Is it easier than IP or harder than IP? It's easier, right? Because it's fixed rate. And you know exactly how mixing a different speeds together. So if we do that, IP and OTN is one and the same. Save us a bunch of money, and if you make this into a real product, make you a bunch of money too. So right now, what we have is a packet over OTN versus packet over SONET before. Packet over SONET called POS. So what does packet over OTN call? Right? That is not fun. So this is a capacity efficiency, what I call one of the possibility to ultimately solve this problem, the capacity problem. If you can do this one, in IP and really packet-optical network, it would be great. And so far, you have seen my slides, right? I made a cardinal thing here. There's 0 pictures. Sorry. People say a picture worth 1,000 words. What I showed here are a bunch of formulas. I would say a formula worth 1,000 pictures. Because that's if you clearly define what you want. If you clearly define what you want to measure. If you go out, actually measure it. How many pictures you can produce. That's which are the truths coming out. All the people talking about that they want to increase their network efficiency or increase their organization efficiency or whatever, right? The executives doing all kind of reorgs. Every time they come in, they have some problem, they do reorg shit. They reorg us around. Does that do anything? If you actually put all actions, all company and department and personal actions into formulas and measure them out, And you see based on time, you are not competing with anybody else. You can use these formulas to actually measure your own progress. And then what can you do from a capacity perspective, from an operational perspective, from the service perspective? You measure as a function of time. That's real progress. That's how the whole thing people are talking about, because now we are not doing just hand waving. We actually have a numerical number you can talk about. Of course, just numbers are not the whole thing. You still need to back up with many other best practices and everything else. However, this is very important, right? And also, networks are not living in a vacuum, right? It's run by a bunch of folks by humans. Humans can be stupidity, right? We see a lot in our own environment, and we can see human ingenuity too. The ingenuity comes from you look at yourself, look at your own organization, look at your own company in truth, in measurable numbers, and then you see the truth. Then you figure out what to do and going forward. So I'm presenting here is not just a bunch of formulas, but they could be used to actually advance a business. And so this conference is everybody is expert here, and I don't need to say too much. And all this efficiency we talk about, the service, the capacity, the operations, what actually can improve that is the control plan, right? Now the SDN, everybody's automation, we heard about all the things we want to do, is actually using the control plan to improve your network. And control plan can be defined in many, many ways, right? And people using the whatever you want to talk about to actually do this thing. But the important thing, you need to understand that the control plan, what you want to do is trying to use software to do a global observation and global control and global optimization. And the problem with that is if you do not have a clear and defined and a control plan, and the message control plan equals a very chaotic world for your network. And of course, you can have many, many ways to do. I mean, I don't need to say too much here. And the more intelligence you put in your network, it's most likely you're achieving a higher network efficiency. So that's what in the next few years probably we can see. Thank you.
Ooh, questions? Time for questions? Yes. Matt Petak, Yahoo. I find your concept of poo very creative. One question I had about your poo, which is, you talk about marking these fixed 16 kilobyte frames with traffic engineering information that would tell it where to go. This traffic engineering hand wave, is that going to be IP addresses? Is it going to be magical MPLS tags? Any thought on how you would actually mark these constant rate 16 kilobyte frames as to where they ultimately want to go in a network?
Now you're asking the little nitty-gritties of that particular slide, all right? So let's think about this. Right now, without any of these capabilities, where do they go? They go exactly where you ask them to go. The optical layer, you have this color interface, right? This color interface sync up with the color interface on the other side. They light up a wavelength. That's where they go. They don't go anywhere else. In the middle, you have all the ROADMs in the middle. They go optically express through. There's no yaw. Optically route through. So there's no way you can intercept anything in the middle. Zero chance. So all the optical communication between two color interfaces, two wavelengths. Inside the wavelengths, say suppose 100 gig. And the connecting to the router is a bunch of 10 gigs, right? 10 by 10 gigs. It's 10 gigs going in. So that's OTU 2 going in. 10 gigs. And now each 10 gig coming in, you see here you have 10 gigs coming in. 10 of 10 gig coming in to form 100 gig. What I'm talking about is this. Before they come in, join your wavelengths. This 10 gigs, how many frames of them they have? If you say 100 gigs every 3 microseconds is 1 frame, and the 10 gig come in every 12, 13 microseconds, right? So all these frames come in because they're 10 times, right? So you 30 microseconds to go in. So in this case, what I'm talking about is say, okay, you know exactly where this port is going to from this port going to that port anyway. So now you say here, can I, because a large number of those frames could be empty, can I squeeze in 20 10 gigs flows into that 100 gig wave? Can I do that?
So you're basically looking at doing lambda tags on the entry, carry the lambda tag across to the far side, and then peel it back out based on that?
Yes.
Okay, just needed the clarification.
And in many places, and you need to regenerate, right? Some network circuit you need to regenerate going more than 1,500 kilometers, you have to regenerate, right? What the regenerate is you're going up to the ROADM, you do OEO, you have this, all the 10 gigs, 100 gigs come together, and you regenerate going in some other direction. Also, at the intersection of your fiber junction, you have routers coming here to hook up. You do a local transition, right? This is a transient network right here. When you have multiple wavelengths coming into other places, but by definition, the traffic actually going to a single direction on the other side. What do? You have 200 gig coming in, you have to have 200 gig going to the other side. Do we? We have to. Because it's a perfect match. It's a synchronized network. But if you know in this 200 wavelengths, 100 gig wavelengths, you have a large fraction of them are not useful. Can you drop them and send them out in a single 100 gig wavelengths? You could.
You get into the statistical multiplexing headache, though, of can you do
Yes.
that reliably enough, or do you end up with a congestion? It's an interesting concept. I think there's a lot more devil in the details that you would
It
have to work
is
through.
all the devils in the details.
Yeah.
I'm not saying this is actually doable, but I say, do you think it's worth to do?
It's an interesting mental exercise, but I'm not sure you're going to see hardware vendors rushing out to do it tomorrow. But thank you for the thought exercise.
Yeah, exactly. Because I have proposed this for a while. I haven't got a single one say, I'm going to do it. I say, probably, that's fine. I just need one guy. Just one. If somebody did it, you will see. Thank you.
Thank you very much.